Okay, good morning, 6th grade. I know it's Memorial Day as I am posting this, but I want to give you guys the information that you're going to need for this week a little bit early, just so if you wanted to do it a little bit early, you get done a little early, and then you're done by Friday, and you don't have anything to do, and you have a 3-day weekend. I mean, I know you already have a 3-day weekend before this, but I figured if you want to space it out that way, it's up to you to space them out when you want. So, first things first, as always, our work is always due by Sunday at midnight, so that it gives teachers enough time to read over all the information and give you feedback. I try to give my feedback as early in the week as I possibly can, so I know tomorrow I'm going to be working really hard to do 6th grade feedback for anything that was turned in last week. I started seeing some of the videos and slides come in, and I'm really excited to read about your science of sports. So, first off, right here we have the pacing guide for this week, and I am keeping with the idea of using the checklist over here. So, for the pacing guide, just a quick overview here. Each day takes between 30 and 40 minutes to complete. The first day we're focusing on the basics of electricity. Second day we're working on static electricity and circuits. The third day we're working on magnetism. And on the last day, you're going to be doing research about any device that you want to learn more about. So, starting on the first day, our video is just a Bill Nye video. The link is right here, and there's a short sheet that goes along with it. I said it takes about 10 minutes to complete the sheet, but if you're doing it as you watch the video, it will take less time. So you can probably get that done in about 26 minutes. On the second day, there's two parts. There's a static electricity part, and there is a circuit part. So for static electricity, what the first thing you want to do is watch this 3-minute video. Then there are 6 static electricity activities that are on this website. I would like you guys to either do one of those activities or look up videos about those activities. If you do not have the supplies, please do not go out and get them yet. And then all you need to do is write a short summary of what you learned in this document. For the circuit playground, this one's kind of cool. When you click into it, you're going to see that you have a circuit playground Google Doc and a website that you have to visit too. So the first thing you're going to want to do is open up the website, which takes a second to load. It doesn't matter to me if you're on the intro or on the lab. Both of them will have roughly the same exact information. In the Circuit Playground Google Doc, when you open that up, it will look like this. The first thing it asks you to do is find a way to make a single light bulb light up with as few parts hooked up as possible. When electricity flows through wires to make something work, like a light bulb, it's called a circuit. So what you're going to do, you're going to take the items from here. Notice that there's a scroll down button, so there's a bunch of different objects that you can use over in the toolbar, and you're going to want to make at least one of the light bulbs go. So notice there are 2 points that you probably need to have hooked up. I'm not going to do this right here, but you're free to use any of the different objects. You're going to follow along with what this Google Doc asks you to do to kind of get an idea of how different circuits work. There are parts that are not numbered that explain what is happening in some of the vocabulary, and after each one of the questions, you should write an answer using your prior knowledge or something that will show me that you have learned. So remember, we talked about conductors and insulators before. You're going to be talking about the objects that are over here and if they are conductors or insulators. On Thursday, we're going to be doing a very closely related topic, which is magnetism. So there's just a quick 4-minute video here on magnetism. There's an activity on how to make a compass out of objects that would not normally be a compass. And then a small document where I'm going to ask you to write what you learned from the compass activity. And then finally, Friday, this one actually doesn't have anything that you have to open up, but if you go into the assignment, you're going to click Create, and then however you want to present it is completely fine with me. So first, you're going to choose a device that has electrical energy. Either it uses static electricity or magnetic energy or electron movement that allows it to work. Then you're going to make observations of your device. You want to look for where it's getting its power from. You're going to say how the energy flows through the system. So for light bulbs, where does it go in? Where does it go out? And if there are any switches, lights, resistors, anything from that circuits lab that is utilized in your design. Finally, you're going to take pictures of your device and explain how it works. Now, that does not mean that you're going to take an explanation from the internet, copy paste, put it on the document, because that's what we call plagiarism. You're going to write this in your own words. And believe me, I always know when somebody's not using their own words on this. If you guys need any help, please remember to come to office hours. I'm sitting there every day waiting for somebody to come on and ask for any help. I hope you guys have a nice week. Hope you guys had a nice Memorial Day weekend. And I hope to see you guys at morning meeting.